Hey, ANPers, this is Dr. Jones checking in. This is ANP1 Lecture Test 3 video, checks notes 6 on page 7. So we are talking about, first of all, here's the pictures. So at 4 weeks, you grew tiny little limb buds. The arms grow before the legs, and then the little legs. And here at 5 weeks, you start to make a hyaline cartilage model of where all the little bones are going to grow. See, little limb buds, little lower limb buds a little bigger at 5 weeks. And so then here it shows how the arm, the shoulder develops and how the hip develops. So you make these tiny little bits of hyaline cartilage, and then they grow into the shape of the bones. And then they start to ossify. Okay, so here you can see the little shoulder joint, and here you can see the little acetabulum and the head of the femur. And so then here you were at 10 weeks where you have little spots of bone. The skull is not endochondral ossification, it's intramembranous ossification. It grows inside the dermis in like a membrane, a fibrous membrane. Whereas most of your bones are a hyaline cartilage model that turns into bone. So that's endochondral within cartilage. Endo is within. And then here at birth, you can see there's mostly bone where it needs to be. The epiphyseal plates are cartilage, hyaline cartilage that is maintained, it's kept. It has not turned yet and won't until you quit growing entirely in height. Lots of ways to grow, but in height. And so some people will tell you that babies are born with 3 times as many bones, which is poppycock. They actually have fewer bones because they don't have any wrist bones when they're born at all, not even a little bit. But on an x-ray, it looks like 3 times as many bones because each long bone is 3 bones because there's a bone at the epiphyses and a bony diaphysis, but then cartilage at the metaphyses, which doesn't show on an x-ray. So it looks like 3 bones, but it's 1 bone with 2 growth plates. So that's why. So people say that, but it's wrong. Completely wrong. It's an understandable. It's kind of like an acorn. So like an acorn is like from an oak tree. And when I was real little, kindergarten, I asked my mom, if you plant an acorn, does it make eggs or does it make corn? Does it grow eggs or does it grow corn? And so these are called acorns because they're things that sound like something else and are commonly mistaken. Let's put a does not equal. Acorns do not equal eggs plus corn, or corn, and or corn. Okay. We are on the top of page 7. What is the difference between ossification and calcification? So ossification, which is also called osteogenesis, is the formation of bone. There are 2 main types: the endochondral ossification, where the bone replaces a hyaline cartilage model. It's also intramembranous ossification, where the bone replaces fibrous connective tissue in the dermis. These are called dermal bones, and it's how the majority of your skull bones grow. So that's ossification. You form bone, and it has all the structures that we talked about. It has osteons and central canals and the bone cells and all of that. So it's bone, but in the bone model. Okay. Calcification is a process of depositing calcium salts. So it's just turning something calcium-y. So this does happen during ossification. So when you When your osteoblasts make the osteoid, that's part of ossification, and then calcification is when you lay calcium salt on that osteoid. So the calcification is part of ossification. This is a picture of osteogenesis progressive. There's a term where sometimes after an injury, the muscles respond to the injury by growing bone in the area. But that is actual ossification / osteogenesis that includes calcification. So a place where you would see calcification without the ossification / osteogenesis would be like a calcium-based kidney stone, where you're making a concretion of calcium, but no bone shapes, no osteons, no bone cells, just a clump of calcium that has aggregated, that has calcified together, or like a calcium-based gallstone. You can have cholesterol gallstones or calcium gallstones. So if you're making calcium-based stones in places where they don't belong, then that will be just calcification without ossification. So that's the difference, is osteogenesis, ossification makes bone with the osteons and lamellae and the bone cells and the whole shebang, whereas calcification can be part of ossification, or it can just be kidney stones, which it sounds excruciating. Gallstones aren't fun either. Okay, so how to make a bone from a hyaline cartilage model. Endo, which means within, chondro, which means cartilage. So endochondral ossification. So step 1, before that, endochondral ossification bone replaces an existing hyaline cartilage model. Number 1, the cartilage model enlarges, it embiggens, and it makes these little struts or empty cavities in the center. Number 2, the blood vessels. So the blood vessels are always going to be key, because growing bone is an energy-intensive process. It requires a lot of blood, a lot of oxygen, a lot of nutrients, a lot of sugars, and yada yada to make ATP. So the first step is always going to start with blood vessels grow into the area, and then we will make bone. So we've got blood vessels go into the perichondrium, and the chondroblasts that are there, cartilage builder cells, will differentiate, turn into osteoblasts, which are bone builder cells. And then they start making a little collar of bone around the edges of the diaphysis, all the way around. This is a cut down the middle, but remember, this is a 3-dimensional cylinder, so all the way around the can of soup. Okay, step 3, blood vessels. Blood vessels enter the central shaft, and that develops a primary ossification center. The primary ossification center in the long bones is the center of the diaphysis, and the primary ossification center is the first place where you get ossification, primary first. Okay. And again, fibroblasts turn into osteoblasts. Here we had chondroblasts turn into osteoblasts. Now we've got fibroblasts turn into osteoblasts and build bone. Okay, blood vessels, blast cells differentiate into osteoblasts, and then we build bone. That's how that works. Number 4, osteoclasts remodel. So we built bone inside here, and now we're going to eat out all of that bone. The bone is got to be destroyed by osteoclasts. Remember, the osteoclasts are giant multinucleate cells with acids to dissolve the calcium salts and proteolytic enzymes to dissolve to eat up the collagen fibers, which are the 1/3 of the organic matrix. The calcium salts are the 2/3 of the inorganic matrix. So we destroy all of that with osteoclasts, and that is what develops our medullary / marrow cavity. That was number 4. Number 5. My head is in the way again. Bye-bye. Go, go. No, no. Okay, that works. Secondary ossification centers are formed in the epiphyses when blood vessels move in and osteoblasts are differentiated. So the blood vessels move into the epiphyses, and you get your 2 secondary ossification centers. So in some of the long bones, like the upper and lower limb bones, this secondary ossification centers develop before birth. In smaller long bones, like the phalanges, it'll be a little later. Okay. Oh, step 5. I think we're good. Yeah. Secondary ossification centers, epiphyses. So again, that's why they say babies are born with 3 times as many bone, but it's not. It's one bone. It's just still developing. Okay. And step 6, the original hyaline model persists. It is maintained. It stays. That's what that means. And it stays in 2 sets of places. It stays as the articular cartilage and also at the epiphyseal plate. So this part will turn into bone, but this will stay hyaline cartilage, as will the epiphyseal plate, which is, of course, at the metaphysis. The epiphyseal plates are at the metaphyses. Okay, that was 5. 6. Did I not have a 6? Oh, that was 6. Oh, we're on 7. Okay, fine. The bone grows in length by adding cartilage to the epiphyseal side. So we're going to add cartilage here. At the same time, change pen colors, we're going blue, the diaphyseal side grows in bone. It ossifies this cartilage. And this grows more cartilage at the same rate that this cartilage ossifies, becomes bone. So you end up with the 2 growth plates staying the same width, but moving further apart as the kid grows, usually overnight, and generally right after you've bought new long pants that were longer than ever, and they fit for like a week, and then my 14-year-old, who's my height, started the lockdown about my eyeballs. Just every time we buy more long pants. And he hates shopping, like clothes shopping, hates clothes shopping. My daughter, you can open the Target app and hand her the pad and she will give it back with clothes in her size in the cart, ready to go. Like matching outfits, you know. And my son's like, I don't want to pick out clothes. Husband has decided we're going to take them out in public and just make him try on the pants. I think the problem is we've been trying to buy him boys' pants, and I mean, he's wearing like a size 12 shoe. I think he's just past boys' pants. We're going to try it. I'll let you know if we find anything that fits him for more than a week. Okay, so puberty. Speaking of, at puberty, the whole time the kid is growing up, the epiphyseal plates stay the same width. They're just moving further apart until puberty. Puberty, you have lots of sex hormones. The male sex hormones are called androgens. The main androgen is testosterone. The female sex hormones are estrogens and progestins. We'll do that next semester. So the sex hormones increase bone development. So while cartilage is being added on the outside at the same rate, the bone is now being added faster. So the epiphyseal plates at puberty begin to narrow until they close. And once they close, they look like this, and it goes from an epiphyseal plate to an epiphyseal line, which is still at the metaphysis. And the epiphyseal line shows that shows skeletal maturity. It shows that that person cannot grow any taller anymore because they can't. Their growth plates have closed. So that's 7. The bone grows in length by adding cartilage to the epiphyseal side of the epiphyseal plate. At the same time, the diaphyseal side of the epiphyseal plate is turned to bone. This means that the epiphyseal plates remain the same width during bone growth until puberty, and I already told you what happens at puberty. The epiphyseal plates become narrower because sex hormones increase the rate of bone growth. Now you need thyroid hormones, growth hormones, and sex hormones all to stimulate bone growth. So a lack of any one of those classes of hormones can interrupt the growth processes. So you tell skeletal maturity with a right hand x-ray, and you can see right here a beautiful shot of the epiphyseal plates in a kid who's still growing. There's a classification system with Roman numerals 1 through 5, and I used to be able to tell you all of that. But I can still tell you this. See, 1, 2, 3, 4, 5, 6, 7. 7 of the carpals have calcified, so this is probably a 6 to 8 year old kid. So effectively 7 wrist bones, a 7-year-old. So now, on this next picture, you can see the little epiphyseal lines a little bit right there where the arrows are, kind of just barely see. So the cartilage is a radiolucency, which means it's not dense enough to show up on the x-ray. And the epiphyseal lines, let's see, where's that other epiphyseal line hit? Like this is a radio opacity. It is radio opaque, meaning it shows up white on the x-ray. So bones are radio opaque, and the cartilage is radiolucent. Lucid means clear. So radio clear means clear on an x-ray. Okay. And to be clear, bottom of the page before we turn the page, what allows the bone to grow in length? The epiphyseal plates, the growth plates. All right, this has been A&P 1, lecture test 3, video. Let me find my little post-it where I'm keeping track of the video numbers. This must have been video 7, because we did Noteset page 8. That's 7. This is 6. I've completely lost track. Okay, so we already did endochondral ossification. No? Yeah? I don't know. Periosteum, endosteum. Did I just record this video twice? Okay, we're gonna call it. This has been a mildly confused video about A&P 1, lecture test 3. We're not quite sure which video or even which page we just did. So maybe I wrote it down when I started. Yeah. So this was video 6 on page 7. That makes sense. Yeah, that makes sense. We're going with it. Okay. So thank you as always for tuning in. It's good to virtually see you here. The education must go on. Dr. J out.